Hi everyone, this is Richard from Rigid Math here to bring you a video on substitution. So today we're going to talk about how to get the point of intersection of two linear systems. So remember that a linear system in grade 10 math is actually just two variables and two equations, and what we're looking for is actually the point of intersection of those two lines, right? So remember, each equation actually represents a line, and if you were to rearrange each of them, you'd probably get like a y equals to mx plus b form. But there's actually like a nice method of being able to use substitution to solve for each of the variables, right? But we'll get more into the visual interpretation of that later on. But anyways, let's just begin. So I'm going to just rewrite each equations in vertically like this and reformat it like this. It's not necessary, but I'm just showing it like this because the question sort of put it side by side, but I'm doing it like this to just make it look easier, right? So then what we're going to do is then we're going to want to rearrange one of the equations so that we're isolating for one of the variables. So then we can use that variable to substitute it into the other equation. So in this case, we're probably going to use the first equation because it's a lot easier to isolate for the y there. So as you can see, there's like a y that's left alone in the left side of the equation, so we could probably just rearrange for it. So we're going to move the 3 over to the left side and then the y over to the right hand side. When you move the 3 over to the left hand side, it becomes minus 3, and then when the y goes over to the right hand side, it becomes a positive y. So we're going to substitute this equation star. I labeled it as star. I'm going to substitute it into the second equation 2. So when I rearranged it, the y becomes 2x minus 3. So when I substitute it, I make sure to substitute it in brackets. So I put in 2x minus 3 as the expression for y. And then I'm just writing this down to just tell you guys to remember to, whenever you need to substitute anything in math, you always have to remember to always substitute in brackets, right? So, because I get a lot of times when I see students do math, they forget to substitute expressions in brackets, and it leads to a lot of errors. So all of this is equal to 9, and then I'm just going to move on to the next step. So now the 4x plus 2x, when they simplify, they become 6x, and then it's 6x minus 3 is equal to 9. But I want to isolate for this x now, because remember, after I substituted the y expression, we're only left with an equation with x, right? So I rearrange for the 6x equals to 12, and then I divide both sides by 6, and then I get x equals to 2. So now I know what the x coordinate is for that point of intersection. I need to know what the y coordinate is. So in this case, I'm going to substitute x equals to 2 into any one of the equations. It doesn't matter which one. There's a lot of fluidity in these steps, but I think I'm going to substitute it into the first equation because it's a lot easier to just rearrange it for y. So in this case, I will just substitute x equals to 2 into equation 1. So I'm going to substitute it in, so it's 2 times 2 minus y equals to 3. And then I just have to rearrange for y now, so I just move the 3 to the left hand side, and then I move y, the negative y, to the right hand side, so that I can just isolate for y. So it becomes 4 minus 3 is equal to y. Then I'm just left with y is equal to 1, right? So that's how you find a point of intersection. So remember, these two variables, x equals to 2, y equals to 1, they represent the point of intersection of the two lines. So I'll explain that more in another video where I discuss the visual interpretation more. But for now, all you need to know is that this is how you use substitution to solve for a point of intersection. But I do draw a little bit of a diagram here just to show you guys that. And although the lines on that diagram, they may not be to scale, it's just to show you that this is what the solution it represents. It's just the point of intersection of two lines, right? So anyways, this is how you would obtain that, and see you in the next video.